So you must have heard people saying that facts don't care about your feelings, facts are just facts. But here's a question, how do we know something is a fact? Well, on that you might say is that facts are supported by research, science, statistics, numbers, and numbers don't lie because numbers are just numbers. But when presented, they can be confusing and misleading, just like your girlfriend. And did I just assume that you have a girlfriend? Anyway, that's not the topic. What we're going to talk about in today's video is that how graph, charts, research, statistics, and numbers lie, or at least confuse or mislead us. And don't worry, we're not going to talk about mod, mean, or median because I failed my mathematics class, so I have no right to teach you anything about mathematics. And I'm also not going to talk about how some people cherry pick some of the stats that supports their agenda. No. We're going to look at some of the examples that will tell you that how these graphs or research or statistics were lying and confusing. So my name is Zishan Ali, and you are on Diary of a Brown Boy. So we're gonna start from very simple things because I know that we are stupid, that we can't understand complicated things without understanding simple things. So let's first start from charts. So here you can see a graph, and the graph talks about which party supports homosexuality.
Haram. So not halal mode.
I am not telling them to be homosexuals, it's just an example. Sorry. Please let me do my job. Alright, so this graph is about which party supports homosexuality more. Is it the party A or is it the party B? So when you look at it at first, it will look like that the party A supports homosexuality much more than the party B. Right? So take a look at the bar, where it is starting from. Well, it is starting from 90%. So if we will start the bar from 0%, that is how it will look like. Now the difference doesn't feel quite a lot. But if we change the bar the way it was before, then the difference feels quite a lot. And that is how you change the story. So change the bar, change the story. Change the bar, change the story. So by changing the bar, you can completely change what the people will understand by looking at the graph at their first sight without thinking about anything. So this is how a lot of people misuse this bar, and there are some examples. Let me give you one. Now take a look at the bar. Is it showing you the real story? What is really happening? It isn't. So this is how the bar graph actually lies to you. And now let's talk about line graphs. So in line graphs, we have both the x-axis and the y-axis. X. Ooh. I'm not talking about your X. I'm talking about axes that exist in graphs. This graph is about the GDP of a country. Okay, now take a look at the graph, and I want you to try to find what is wrong. You can pause the video. If you don't find, then let me tell you, let me help you out. So we all know that the bitch is in the details. If you look at the x-axis, the normal duration of years that they used were of 2 years, and then out of nowhere they made the duration of 5 years, and the space between the both points are same as for the 2 years. And now if we will change how the graph would actually look like, that is how it will look like. Now you might be thinking about how this graph can be misleading because it is going upside. Well, here's the thing, a lot of people use this technique in order to hide something important that happened. So for example, if we look at this graph, and there you can see a decline in the GDP. Now it can tell you a lot about what happened at that point or at that moment, and it also makes you look like that the GDP was growing in a very good way. This is how these graphs can be misleading. So now let's move to the next thing. So in order for you to understand a graph, you need to know about each and every variable and its implications that the graph is talking about. So let me give you an example. Look at this straight line graph. So if you look at that graph, it doesn't look like that a lot was happening, but I want you to take a guess at how it can be used in a misleading way. Before I tell you, this is not a political video. I'm not giving a real life example, so you won't get stuck with the politics.
Oh, I believe in climate change.
I don't believe in climate now. Just get to the point. What are we talking about? So this graph is talking about carbon dioxide, and the time span they're talking about is of a lot of years. But we know that a slightest change in the carbon dioxide can be very harmful in so many different ways. So if you will take a look at the data of 1 year, and if the data looks something like that, then that means that the rate of carbon dioxide has actually increased, which is bad. If you don't know about that, if they show you this graph instead of that graph and you don't know about the details, then they can say, oh,
everything is stable.
Nothing has happened a lot.
Everything is cool, everything is fine. Now next time you will know if someone is actually playing with you. Ask them questions about stuff. So this was all about graphs. Now let's move to statistics. So how statistics can be misleading. Okay, let me tell you how. So I will give you an example. That example will be like, what, how, and let me tell you what is the example. So there was a research that was done in UK, United Kingdom. According to that study, the conclusion of that study was the people who smoke cigarettes live more years than the people who don't smoke cigarettes. And yes, That was the conclusion. And now you'll be like, how it can be possible? How? I can tell you what really happened. So to conduct this research, there were two groups that were taken. The first group who smoked cigarette and the second group who doesn't smoke cigarette. So when they looked at the details, the group that was not smoking, they were already old people compared to the group one who were smoking cigarettes. And we know from a fact that people who are older, they're more likely to die early than the people who are young. And because we missed that factor or variable, the research showed a very bad result. Okay, and just like that, there's so many researches that can have the same error or same problem because we don't know which factors to include and which factors to not include, and it's hard to comprehend each and everything. And I speak so much, don't I? Anyway, just continue the video. So we need to be very careful with the statistics, and this problem is actually called Simpsons paradox.
Vacation to Barnacle Bay!
Not those Simpsons. Come back, you're adult now. You shouldn't be watching those things. Simpsons paradox, and that paradox exists in statistics. And in order to understand that paradox, in simply is that there are variables which can influence the whole conclusion of a statistics, and if we miss those variables, the results can be very wrong. Anyone who knows the information, they can make any type of research and you wouldn't even know. So whenever someone comes up with a research,
Look at this study proves something, and facts don't care about your feelings.
study the study, or study the stats, I mean, okay? That was about stats. Now let's move towards something interesting, and that is about advertisement. So when I was growing up, I used to watch this ad a lot that out of 10, 8 dentists suggest this Colgate. When I watched that commercial, I came to this conclusion that it means that this toothpaste is the best, but it was a lie. It wasn't a lie, but it was misleading, and it was very carefully used. So let's say that you want to do a research in areas X. There are 10 dentists, and you want to see out of all the toothpaste, which toothpaste are suggested by all these dentists. So you make a questionnaire, you go to them, and they answer them. I prefer this, I prefer this, I prefer this, and they give multiple answers. And now when you come back and you process and you make the result shows you that out of 10 dentists, 9 dentists were saying that you should use Sensodyne, and at the same time 8 were also saying that you use Colgate. But now you can use it in a very careful way in advertisement, and that is how it can be misleading, because I was misled by that. So I remember it. They lied to me. How dare them? I don't use them anymore. Okay. So now let's move to the next thing, and we're going to talk about some of the numbers. So let's say hypothetically that there is a university with the name X, and in the first year only 5 students failed from that university, and in the next year 10 failed from that university. So here's a question for you. Is it a 5% increase or is it a 10% increase? Because if we add 5 into 5, it becomes 10, but we can also say it's a 100% increase. So now let's take another example. When you were stupid, you went to have a job, and the wage that was given to you was $5 per hour, and then you proved yourself, and now your wage is $10, and now it can be called a 100% increase in your pay. But in the example of school, which tells a more real story, this one. And this is how numbers can be very misleading oftentimes. So let me give you a real life example. So there was this pill that was used in UK, and it was for birth control, and out of 700 girls who took the pill, 1 girl had a blood clot. And then the next year they made an updated version of the pill, and what happened, instead of 1 girl, 2 girls got their blood clot. Now the difference is not very big, but then a lot of news outlets started reporting it so much and in a very bad way that people were misled, and the next year what happened is that there were so many unwanted pregnancies. Unwanted pregnancies. I can't even have a wanted pregnancy because I'm a man. Okay, anyway, and there are more complicated things that are also used in all those things, like correlation is not always causation, prosecutor's fallacy, how in court statistics were used, and how these people failed very miserably. But I will make a part 2 for that because those things will be very complicated. So this was it for today's video. I hope that it was entertaining, it was fun. Take care of yourself, and adios.